So in this video, I'm going to explain curvilinear regression. Curvilinear regression, also known as polynomial regression, is a type of regression analysis that involves fitting a curve to a set of data points. Unlike linear regression, which assumes a linear relationship between dependent variable and one or more independent variables, curvilinear regression allows for a more complex relationship between the variables. So in curvilinear regression, a polynomial function is used to fit the data. The degree of the polynomial determines the complexity of the curve. For example, a quadratic equation that is to the power of 2 would produce a curve that is called it as a parabola, while a cubic equation degree of the power 3 would produce a curve that is more complex than the parabolic curves and has multiple inflection points. Curvilinear regression can be used in situations where linear relationship between the variables is not sufficient to accurately model the data. Curvilinear regression is a statistical technique used to model the relationship between a dependent variable and an independent variable when the relationship is not linear but can be approximated by a curve. It involves fitting a curve to the data points using a mathematical function and estimating the parameters of that function to best describe the relationship between the variables. The most common form of curvilinear regression is polynomial regression, where a polynomial function is used to fit the data. The general form of polynomial function is y is equal to b naught plus b1x plus b2x square plus so on bnx to the power of n. This is the general form of polynomial function we can represent, where y is the dependent variable, x is the independent variable, and b0, b1, b2, so on, bn are the coefficients of the polynomial function, and these coefficients we can determine directly by using the R programming. The degree of the polynomial determines the complexity of the curve and how well it fits the data. A higher degree polynomial can fit the data better but may lead to overfitting and poor generalization to the new data. Curvilinear regression can be used in various fields such as finance, economics, biology, engineering, and physics to model nonlinear relationships between variables and make predictions or gain insights from the data. Here are some common problems that can be solved using curvilinear regression. One is predicting future trends. Curvilinear regression can be used to model the trend in a data set and predict future values. For example, a company might use curvilinear regression to predict future sales based on historical data. Identifying nonlinear relationships. Sometimes the relationship between the independent and dependent variables is not linear. Curvilinear regression can be used to model nonlinear relationships between the variables. Number 3, extrapolation. Curvilinear regression can be used to estimate the value of the dependent variable outside the range of the independent variable. However, it's important to note that extrapolation can be less reliable than interpolation because it involves making predictions outside the range of the data. So interpolation. Curvilinear regression can also be used to estimate the value of the dependent variable within the range of the independent variable. Interpolation can be more reliable than extrapolation because it involves making predictions within the range of the given data. Overfitting. Curvilinear regression can be prone to overfitting, which occurs when the model fits the training data too closely and performs poorly on new data. Regularization techniques such as L1 or L2 Stock market analysis. Curvilinear regression can be used to analyze stock prices over time and to identify trends in the market. Engineering. Curvilinear regression can be used to model the relationship between different variables in an engineering system, such as the relationship between temperature and pressure in a chemical process. Like several other processes, to take the examples, there is a lot of examples we may cite in engineering examples. Climate modeling. Curvilinear regression can be used to analyze climate data and to model the relationship between temperature and other variables over time. Medical research. Curvilinear regression can be used to analyze medical data and to model the relationship between different variables, such as the relationship between age and blood pressure. Traffic analysis. Curvilinear regression can be used to analyze traffic patterns and to model the relationship between traffic volume and time of day. A researcher just will see the one numerical problem for better understanding of curvilinear regression, how we can model it and how we can solve the problems. Let us take one real problem. A researcher wants to model the relationship between number of hours studied for a test and the test scores. Data collected is shown in the table below. Use curvilinear regression to find the best fit polynomial of degree 2 for the data. Now let us see the data. This is the data is given hours studied and test score. If studied 1 hour, is score 60. Studied 2 hours, it scores 75. 3 hours studied, 85 scored. 4 hours studied, 90 scored. And 5 hours studied, 95 scored. So with a given data, just you have to use the polynomial equation. We can derive the polynomial equation. Now let us see the solution. Using a curvilinear regression model of degree 2, we get the following equation. The test score is equal to a plus bx plus cx square, where a, b and c are the coefficients to be determined. So solving for the coefficients using the least square method. There is several methods are there. This method is best suited here. Using the least square method, we get directly these coefficients. You can use R programming, and from R programming also, you can obtain these coefficients directly by giving the input data. So A is equal to, so in that after getting these coefficients, that value A is 53.5714 and coefficient B is 17.8571 and coefficient C is 3.5714. Now substitute these coefficients in the above equation test square, that is A plus Bx plus Cx square, and that is the best fit polynomial equation. So the best fit polynomial equation is test score is equal to 53.5714 plus 17.8571 hours studied plus 3.5714 into hours studied whole square. This is the best fit equation. I hope all of you understand this curvilinear regression, how we can use it for solving the several practical problems.